Hi guys, one of the most important concepts in C++ and as you're learning about programming is to understand how we handle input. And sometimes it is kind of confusing for new programmers. So in chapter 3 we cover the basic idea of input. So first of all you really need to learn about the basic rule sets that is explained in the chapter. Okay, so if we have a character, the rule for the extraction operator is to skip the leading white space, find and store only the next character, single character. In C++, it's going to be an ASCII character, so it's only a single byte will be read from the input buffer. And reading stops after the single character. Now, if we want to read into an integer or a double, a numerical value, then again you start by skipping the leading white space. Then you read a plus or minus sign if there is any, and then reads the digits, including the decimal if it is a double. Now, reading will stop on a white space or a non-digit character. So if this is a double is a floating point. So the floating point will have the period separating the whole numbers from the fractional part of the real number. So in the case of double will read plus or minus sign, then all the digits followed by the period if there is a period, and then the following digits until it encounters a white space or a non-printable character. So you have to understand this concept before you even start thinking about the code or running the code. So the second step would be to actually create an application and then test every single one of these examples that is in your book. So in this particular case, example 3-1, you don't really have a source code for that, but we can easily create, let's say, just a simple application. Let's just say a simple hello world application. And in this case, we have integer a and b. So we type in integer a and b. Now we have two integer variables declared, a double z, and then a character ch. And at that point, we can start writing the code to see how the extraction operator works. So the first example is to read into ch. Okay. And it says that the ch will be assigned character a. Now, how do we see that? It is very important that you become comfortable with your IDE and the IDE that supports debugging. So in Visual Studio, you can toggle your breakpoint by either right-clicking on your syntax or just double-clicking on the vertical bar in front of your code. So in this case, our program will stop before it will return, where the return value will end the application. So we want to stop the code before it ends, so that way we can see what is really stored in ch. And in this case, we don't really need a prompt, but if you want to make it a little bit better, then you might have enter value or values if it makes you feel better to have a prompt. Okay, and at that point you start running the code. So in this case the input buffer is empty, so our terminal, the console, will pop up and ask us for an input. After we press enter, then we're gonna reach that breakpoint in our code. Okay, so at this point I type in capital A, press enter, and you can see that CH is assigned A, and the value of A is 65 in ASCII code. So you can see your code actually pauses at this point, and if we continue, then we're going to exit out of the program. So at this point we just tested this line, the first line of code, that yes, if we are reading into CH and CH is a character data type and the input is A, then CH will be assigned A. Now the rule says we're going to skip the leading spaces before we assign a value. So let's test that. So we stop the code, relaunch our application, and in this case I'm going to type in a bunch of spaces, maybe tabs, or you can enter a few times. You can see that the cursor is blinking right at this point. So now I type in capital A, and now I press enter. You can see that regardless of how many spaces I typed in, regardless of how many tabs I typed in, and regardless how many enters I typed in before I pressed A, C++ or the extraction operator basically skips all those white spaces, and it only reads the character A when it appears. So it only reads if anything else but space or white space is in the buffer. Okay, so we just tested that. So let's see the next example. Okay, so we are reading into CH, but the input is AB. Okay, then we're still reading into CH. So now we are in step or example number 2. Okay. So then we run the code again. Let me press a few spaces, then I type in AB as an input. When I type in AB, I press enter. And at this point, you can still see that CH is only assigned A, even though I typed in A and B at the same time. Let me change color scheme. Okay. So it doesn't matter how many characters I typed in, only the first character gonna be read. Okay. Now, just as interesting fact, let me duplicate this. Okay. And we can put in another breakpoint. Let's see what happens in this case. Okay. So we are pausing. We are pausing at the first prompt. And I'm going to type in a couple of spaces and AB. Press enter. You can see that CH is A. Now when I try to read the second line, the second CIN operation, it doesn't stop there to ask me for what is the next character, because B was stored for future inputs. So that's what the presentation is talking about. Okay, so if we only read one CH, we only read A, but B is still stored in the input buffer. So even though A is assigned to CH, B is held for later input. So in this case, the later input was I wanted to read a new character, but since the buffer already had B in it, it never stopped to ask me for B, it just read B. Okay, so let's see. Cn, we are trying to read an integer. What is the integer rule? Read all the spaces, positive or negative sign, if any, and read all the digits until white space or non-digit encountered. So in this case, really quickly, we can just modify this code. And we are reading into A. A is an integer type, so the integer rule applies. Run the code. This time, we're going to type in 48. When you look at the value of A is 48. So I want to stop this, run the code again. Let's see if the rule really applies. I'm going to press a couple of spaces, then I type in negative 48, and then I press enter. Okay, you can see that the value is negative 48. I stop this, run the code again. I want to press in spaces or tabs. Now I'm going to type in positive 48. Press enter. You can see that the sign is not saved, but only the digits are saved. And this is also valid for a negative value. And you can basically test that if you look at your calculator. Okay. If you bring up your calculator and you switch over to programmer calculator and you type in negative 48 negative, see, negative means that the leading bits, when you are storing a value, a numerical value, when the leading bits are ones, it means negative. So you don't really store the negative character. It's the representation in binary that makes it negative. Okay, so if I just type in 48 equals to 48 equals to, see the leading, we just go down to, let's say, a byte. So you can see it that the leading spaces are, leading bits are 0. This is a positive value. While if I type in negative 48 negative, the leading values are 1, and that's what really means a negative number. Okay, so we do notice the positive and negative sign, but you don't really store that character. The unary operator, positive and negative sign, is really just an indication to branch the program to store the value as positive or negative, but you don't really store the actual sign character. Okay, so it looks like it works just like it was advertised in the in our code or in the rule set. Okay, so now what happens? What happens if we are reading into A, where A is an integer, and we are reading a fractional value? So we are entering a real number. So that's what's gonna happen for 46.35. So we run this. Let me type in a couple of spaces, and we can even put in the positive sign. So 46.35, press enter. You can see that in A we stored 46. So 46 is stored. and 0.35 is held for later input. What that means is, because a is an integer, the integer rule says skip the leading spaces, read the positive negative sign, then read all the digits until you find a non-digit character or a white space. In this case, we encountered the period, and integers do not have fractional portions, so it stopped reading at that point. Now to show this, that 0.35 is held for later input, what we can do is stop the code and we can create another cin, and let's read into z. Okay. Z is a double, so when I type in spaces positive 46.35, okay, you can see that 46 is assigned to A and Z gets the 0.35 as a double value. Okay, so it works exactly like the book says, but this way, if you run it through the compiler, you can see exactly what these examples are talking about. So let's go to 5. Okay, so we are in example 5. In example 5, we are reading a double value. The input gonna be 74.35. Okay, so 74.35. I press enter. You can see that Z is stored 74.35 in the variable Z. Why? Because the rule for the double or floating point data type is skip the leading spaces, read the plus or minus sign, read all the digits until you read a white space or non-digit character. But if the non-digit character is a period, that's allowed because this is a floating point data type. So read the period, read the rest of the digits until you encounter a white space or non-digit character. Okay. So this way you can visualize what's in the actual memory. So if we are just typing in 39 without the fractional portion of the value, so it is 39, you can see that because of the data type, it is not just the integer 39 saved, but integer dot and the fractional portion of the real number also stored. So that's what it's trying to show you. Okay. So then what happens if we read a integer? I mean, we read a double and then we want to read an integer on the same command line. So we are reading Z and A, Z, and then we're gonna read A, and we're gonna type in 65.78 and then 38. .78 and then 38. Okay, here I'm just going to show you that yes, I'm skipping spaces. You see here are the spaces. Then I can use the positive negative sign if I want to. Now how many spaces we have in here, it doesn't really matter, right, because of the rule. And then if we use the positive sign or not, that doesn't matter neither. Okay, so when we press enter, you can see that Z is assigned 65.78 just like we said it, and then the white space was skipped, positive negative sign was interpreted, and then 38 was actually assigned to variable A. Okay. So then we can go to example 3-2. So we have integer A, double Z, and character CH. Integer A, double Z, and character CH. So, please do understand you can type in any value that you want, okay? But first, as you're learning, just follow exactly what's in the book and make sure that you use the debugger to visualize what is being assigned to what variable. Okay. So now we have A, CH, and Z. So we're going to read an integer first, then a character, then a double. So that means this is the sequence what we have to prompt the user for. So 57, A, 26.9. Okay. Let me stop this because really need to A, CH, and Z, right? So we need to read A first, then CH, and then we're going to read the value for Z. Okay. So this way you can see this. Okay. So we type in 57 space. How many spaces? It doesn't really matter. Okay. It doesn't matter if we do put in the plus sign or not. 26.9. Press enter. When we go back to the compiler, you can see that the value 57 is assigned to A, which was the first read operation. A was assigned to CH, which was the second read operation, and 26.9 is assigned to Z as the third read operation. Okay. So that was the first example. Second example, here we're gonna show that it doesn't really matter how the user types in the values. So in this case, the user gonna press enter, and even with the enter, we're gonna be reading the Z value because enter is considered a white space. So the only thing that you do in this case, just rerun the same application. So now we type in 57 space A, press enter, and you can press multiple enters too, 26.9. So when we go back to our code, you can see that 26.9 still read perfectly fine, even though 26.9 is not on the same line. So it doesn't have to be in the same line, and it also doesn't matter how many spaces you have between the input values. Okay. So then number 3 is, what if all the values are in separate lines? That doesn't really matter neither. Okay. So in this case, we type in 57, enter, enter, maybe even put in spaces. Okay, and then type in A, press enter, enter a few times, or press tab a few times, even type in positive number, and then type in 26.9. It doesn't really matter. Okay, you can see that the values are still read properly because you understand the basic code rules for the extraction operator for input. But you do have to practice this to feel comfortable. So now what happens if we do not have space at all? Okay, would that still work? So again, you leave everything the same code, and then we look at this and we type in 57A 26.9. Okay, why would that work? Well, first of all, we have to read an integer, right? When we read the integer, what's the rule? Rule means skip the leading spaces, read the digits. So 5 is a digit, 7 is a digit, A is not a digit. So in that case, variable A will receive 57 as a value. Now we are reading into a ch variable. Ch variable is a character. So because a character needs a character input and there is no leading spaces, it will read capital A and stop reading after that because character only needs 1 byte. At that point, we are ready to read into Z. Z is a double data type. So at that point, we're reading leading space. There is no leading space. Positive or negative sign. There is no positive or negative sign. So keep reading the digits. So 2, 6. It's a double, so period is perfectly fine. 9 is fine. But then we reach the white space. Because we reach the white space, it stops reading and it will assign 26.9 to Z. So you press enter and you can see that the values are as we predicted them. Okay, so the user can type it in that way. Okay, so let's go to the next, and you also need to look at what happens when something might not go perfectly fine, right? Or if the user type in more characters than you needed. So in this particular case, again, let's change the code. So we have int abz ch ch1 and ch2. Int ab, we have double, which is z, and character ch comma ch1 comma ch2. Okay, and now we're ready to play with these examples. So we adjust the code. First we read into z. Z is a double, then ch, and then a. Z, first z, then ch, and then a. Okay. So now we run the code again. Okay. Let's see what happens. So what happens if the input is 36.78B34? Okay. So what's going to happen? First, we're going to read into Z. Z is a double. So Z will stop reading as soon as it reaches B. Then we read into a character. Character B is in the buffer. So when we read it, we are fine and we advance the buffer. So we only going to have 34 at that point. And at that time, we're going to read into variable A. So we press enter. We go back to our code and you can see that 36.78 is assigned to Z, B is assigned to CH, and A has 34 assigned to it. So it works just fine. Okay, what's the next example? Again, you might have some spaces in between the values, spaces, tabs, or carriage return, and they're all the same. So it's not going to change our read operation. So we are going into example 2. So we type in 36.78, press enter, capital B 34, press enter again, and you can see that the values are assigned like we predicted them, right? So we have Z 36.78, and we have CH, which is B, and then we have 34 for the variable A. Okay, stop the code. We go back to the next example. Now we need to read A, B, and Z. Okay, so change the code. So we have B, A. So we're gonna try to read A is an integer, B is an integer, and Z is a double. So we run this code. Okay, and our input is 11 space 34, which will satisfy the integer A and integer B, but the code will not continue until we also give a value for Z. So if you look at your code, we have not reached the return statement yet. Okay, we don't have the yellow arrow there. So we're not there yet because we don't have enough input yet for the code to continue. It's still waiting for Z. Z is not assigned a value yet. So at this point, because enters are ignored by the rule, right? We cannot press enter 50 times or 100 times to continue the program. It's going to stand there until we give it another value, let's say 6.7, and now we continue with the program. Okay, so that's why it was pausing the program, waiting for the user input, and if the user just presses space, enter, or tab, it's not going to be enough as an input in this particular case. So that's what this example was trying to show you. Okay, so then we change it to only input A and Z. Okay, so we only inputting A and Z. We run the code. Okay, so if you don't have the breakpoint set, you don't see, you cannot visualize what's in what variable. So in this case, the user input is 78.49. Okay, what is it that we're trying to read? We're trying to read into A is an integer, and Z is a floating point. So what's going to happen? The integer will stop reading after the 8, and then we start reading into a floating point. The floating point rule says the period is perfectly fine, and then 4 and 9 is a digit, so the floating point will stop reading when it sees the empty or white space. So integer should have 78 in it, and the floating point should have 0.49. Okay, so then we go back to the code. Here's 78, and here's your 0.49. Okay, so it might be strange to understand why this happens, but make sure that you do run through the code and try to make sense out of this by using your debugger. Okay, so now we're gonna have CH and A. Okay, so we're gonna read into A after we read into CH. So CH is a character. Right? So let's run this code. Okay, let me bring this up. So we are on example 5. So the user input is 256, right? What is the rule for CH? It's just looking for a character. So it's gonna be happy to see a number 2. It doesn't know that you try to type in 256. So when we press enter, you can see that CH is 2 and only 56 was stored into A. So this can be a strange result if you don't understand the rules, how the input rule can happen, or how the input rules work, and if you cannot visualize what is being stored in the actual variables. So it's a very valuable exercise to run through every single one of the examples and not just read about them. So then we're going to read A and then CH. Okay, so now we flip these around, A and then CH. Remember, A is an integer, CH is a single character. So we run this code now. Okay, and again, we're going to type in 256. Now 256 is following the integer rule. A is an integer data type, so that means we're going to read the 2, the 5, and the 6, and they're not going to be any characters for our A or for the CH variable, which is waiting for a character. Okay, if we go back to the code, you can see we're not at the return statement yet. We're still inside the CH operator, where the CH operator is waiting for us to type something in. And then we type in A. And now we continue on. And now we have A assigned to CH. Okay. So first we read a character, then the integer. It split the 256 into 2 as a character and 56 as an integer. In this case, we read the A. A is 256, the integer, but CH was waiting for another input. So that's what this example 6 is trying to show you. So what happens now with CH1 and CH2? Okay, so if I change this to CH1 and this is CH2, okay, oops, make sure you stop the code before you run this. And now you run this example. Okay, so the user input is capital A space or multiple spaces and then B. What's going to be the value when we assign it? You can see that CH1 is A, CH2 is B, because the rule skipped the leading spaces. So it doesn't really matter how we read this. Now, just as an extra exercise, let me just show you one more thing. If we use cin.get instead of just extraction operator into CH2, okay, so first we're going to use a CH1 using the extraction operator, and then we're going to use a member function that is a member of CIN. When you see the period is the member access operator, and get is a function. So it's going to work a little bit differently. Okay, so if I have this program running, and then I'm going to type in capital A space 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 B, and I press enter, what you're going to see is capital A is read perfectly fine, but CH2 is assigned the space character. So 32 is the ASCII value of space. The get function does not skip white spaces. It also reads whatever, it just reads whatever the next character is. So in this case, if you're using this function, now you can see how unpredictable, how strange gonna be your results when a user types in A and B. You're using the function get to read the value, and you're not gonna get the second user input. While if you're using the extraction operator, it doesn't matter how many spaces the user types in between the two characters, the extraction operator will read the first and the second user input. So this is a very valuable exercise, and it gives you a very good introduction how to use the debugger and your IDE in order to visualize your code and visualize what is held in variables. And like in this particular case, you can also see the actual value for garbage values. So visually, you're gonna be more comfortable identifying values in C++, or not just identifying values, but it will help you understand where you make mistakes one statement at a time. It will help you understand what a garbage value is, and it will help you also to learn the ASCII code of particular characters. So like if you look at the debugger this way, even though you typed in capital A, you're going to see 65. So eventually you've seen it so many times that you're going to remember that capital A is 65 without trying to memorize a table. Okay, so there's a lot of benefits of running code like this. Okay, so let's do one more example here. So what happens if I type in, let's say, ch2, okay, and let's read it into A. Okay, so first is a character, second is an integer, and well, let's make it more interesting. Let's call this age. Okay, so I'm trying to ask for your age. And I run this code, or maybe let's print out your age is. Okay, let's see what's going to be your age. Oops, that was not my intention. Okay, what happens what the user typed in? Okay, okay, so first of all we need a character, so I'm going to type in A, and then for age I'm going to type in B. So there is B in the buffer after we read the character A. So let's see what's going to happen when I press enter. Okay, do you see what happened here? We tried to read the character 1. Character 1, ch1, is a character. A was read perfectly fine. But then the user input was B. B is not a digit, but it is in the buffer. It is in the buffer that we are reading, trying to extract the B and assign it to an integer, and we cannot do that. In that case, the buffer gets into a failed state, and when the buffer is in a failed state, it still allows the program to continue. When you see the program continue, if you look at the variables, the integer variables, you see the negative 858,993,460 is the garbage value. So the program continued even though the input was wrong. The program continued, and as a program continued, it happily displays the garbage value, and the user or your code has no way of knowing that the user input was wrong. So that is why eventually it's going to be very important that you validate the user input before you assign, or before you trust user input and assign that user input to a variable. And be careful about the garbage value. Make sure you understand that garbage value can mess up your code really badly if you don't validate user input at runtime. That's gonna be enough for one session, so hopefully that's gonna be helpful in helping you getting comfortable with your IDE and the debugger, and also how you can use the examples in the PowerPoint presentations or in the chapter to help you understand concepts discussed in particular chapters or in this particular chapter. See you guys next time.